In this video, we will be learning a second way of representing the equation of a line called point-slope form. So point-slope form looks like this, where we have y minus y1 with this subscript equals m, our slope, times the quantity x minus x1. So m represents our slope, y and x are left as variables that are part of our formula, just how in y equals mx plus b, we leave the y and the x there. Y1 is the y coordinate and x1 is the x coordinate. So point slope form is useful because all we need to come up with our equation is just a point and our slope. So we're going to plug in our slope and then plug in the x and y coordinates of some point into the equation and we're done. So looking at these practice problems, if we have the point 3, 5 and the slope -4, we're going to plug it into our formula. So we'll have y minus our y coordinate, which is 5, equals our slope -4 in parentheses x minus our x coordinate, which is 3. And that's it. That is the point slope form of our equation. We don't need to distribute anything. We don't need to move things around. This is the proper form of what the equation would be in point slope form. So let's try the next one. If we had -8, 1 as our point and our slope was 2/3, we would plug it in as y minus our y coordinate, which is 1, equals 2/3 in parentheses x minus our x coordinate, which is 8. And then we're done. For the next problem, we have the original formula written at the top there, so I'm going to do y minus my y coordinate, which is 6, equals my slope, which is -2, in parentheses x minus my x coordinate. And my x coordinate here is a -3, so it's minus a negative. If I have minus a negative, I can change that to a positive. So my new simplified answer for my point slope form will be y minus 6 equals -2 in parentheses x plus 3. So remember, just like with slope-intercept form, the original formula was y equals mx plus b. So if you ended up getting something where instead of it being a plus b, it was a minus b, that meant that your y-intercept was negative. So for point slope in your original formula, we're doing subtraction. So if it changes, if the sign changes to be addition, that must mean that your coordinate, whether it's your x or y coordinate, that coordinate was negative. So in this case, we had a negative x coordinate. The next problem shows you what happens if you have a negative y coordinate. Plugging it into my point slope formula that's written at the top, I will do y minus my y coordinate, which is -5, equals my slope 9, in parentheses x minus my x coordinate, which is 7. And so when I have y minus a -5, that's the same as saying y plus 5. So I'll rewrite this as my final answer for the point slope form of the line that goes through this point and has this slope. If we are not given the slope already, then we'll need to calculate it. So in this example, if we are only given 2 points, we're going to first find the slope, then plug in one of the points and the slope into the point-slope equation. Using my slope formula to figure out the change in y over the change in x, otherwise known as the rise over the run, I'll subtract the y values and divide it by the corresponding x values. I end up getting 2/4, which will simplify to 1/2. So my slope is 1/2. From here, all I'm going to do is pick one of the points and plug it into my point-slope equation along with the slope here. So let's say use the first point. If you use the first point, we'll have y minus our y coordinate 5 equals 1/2 in parentheses x minus our y coordinate minus our x coordinate -1. Since it's minus a negative, I'm going to change this to a plus sign in between. And that's my final answer. For practice, let's come up with another point slope equation using the second point. So from here, I would get y minus my y coordinate 7 equals 1/2 in parentheses x minus my x coordinate 3. So now we have two different point slope equations that represent the same line. And just to clarify, there are an infinite number of points on every line, right? Because the line continues on in both directions. And so because there are an infinite number of points, on every line, you could represent the same line with an infinite number of different point slope equations. In this case, we just came up with these 2 point slope equations because these were the points that were given to us. But there are other point slope equations that still represent the same line. To find my slope, I will be doing the change in y over the change in x. I end up getting negative 3 over negative 8, which will simplify to 3 over 8, and this is my slope. Then I can use either point to come up with my point slope form of the line. If I'm using my first point, I would get y minus my y coordinate 2 equals my slope 3/8 in parentheses x minus my x coordinate negative 8. Since I have minus a negative, this sign would then change to a plus. When I figure out the change in y over the change in x, I end up getting 1/5 as my slope. I can use either point to plug it in to come up with my point slope equation. If I use the first one, I will end up getting y minus a negative 7 equals 1/5 as my slope in parentheses x minus a negative 6. Then from here, as we've said earlier, when you have minus a negative number, that would just change to plus. When we use the second point, it's the same process, plugging in the values. Just make sure that when you have minus that negative 4, you can change that to a plus 4. Using our slope formula, we end up finding that our slope of the line that goes through these 2 points is negative 2. Plugging in the first point into my point slope equation, I get y minus 10 equals negative 2 in parentheses x minus 12. For the other equation, I would have y minus negative 6 equals negative 2 in parentheses x minus 20. Since it's minus a negative 6, that would change to the same thing as plus. So I could have y plus 6 and then the rest be the same. To rewrite a point slope form of a line into slope-intercept form, we're going to distribute the slope and solve for y. So y equals mx plus b is the slope-intercept form of the line, and notice that y is completely by itself on the left side. So that means I will have to add or subtract whatever my y coordinate was in the point slope form to get y by itself. We also have on the right side that it's mx plus b, there's no parentheses, so then I will have to distribute whatever the slope was to the inside quantity. So for this problem, I'm going to distribute negative 5x to each of the inside values. Then I will subtract 1 to get y by itself, and my final answer will be y equals negative 5x plus 14. And just to be clear, these 2 lines represent the same line, it's just that they're 2 different forms of the same equation. For the next problem, to isolate y, I will distribute negative 3 to both of the inside terms. Then I will add 2 to both sides to get my final answer that y equals negative 3x minus 19. If you have a fraction as your slope, when you're trying to make your point slope equation into a slope-intercept equation, there are a few different ways you can do this. So one thing that I've been teaching is that when you have fractions, you can just multiply everything by the least common denominator. In this case, we only have 2 in the denominator, so we could just multiply everything by 2. However, as you may notice, in the point slope equation and in the slope-intercept equation, we have the same slope appearing, right? In this earlier problem, we had negative 5, and it appears in the point slope equation and in the slope-intercept equation. So this 1/2 is our slope, and that will reappear in our slope-intercept form. So we know that even if we multiplied everything by 2, we're later going to have to divide everything by 2 again, because we'll end up getting 2y on the left side, and so we'll ultimately need to divide by 2 to get y by itself. So in this particular case, if you do have a fraction that would be easy to distribute, you could just leave the fraction as is. So for example, in this case, if I had y minus 3 equals 1/2 times x, that's just 1/2 x, 1/2 times 8 is half of 8, that would just give me 4. solve for y by adding 3 to both sides, and I get my final equation. So in this case, it was pretty simple to do 1/2 times 8, and so we didn't have to multiply everything by 2 or find other common denominators, but I'll show an example where we would have to do that. And so in this particular example, we could choose whether we wanted to multiply everything by 4 and get rid of the denominator, or if we'd want to find a common denominator that we can use to then add our fractions together. If I just wanted to multiply this out, I would end up getting y plus 4 is equal to 5 over 4 times x, and then 5 over 4 times 10 will be 5 times 10 is 50 over 4, which will simplify to 25 over 2 since both the numerator and the denominator are divisible by 2. Now here's where you have to be comfortable with fractions if you want to use this method, because I will need to get y by itself, which means I need to subtract 4 from both sides. However, now I have a fraction that I'm trying to subtract a whole number from. So what I need to do is find my common denominator. If my number here is 2 and I want to combine these, I'm going to have to rewrite 4 with a denominator of 2. So minus 4 will now become minus 8 halves. Then from this point, I will end up getting that y equals 5/4 x plus 17 halves. This is my final answer in slope-intercept form, and it is okay to get a fraction as a y-intercept. That just means that instead of having your point on the y-axis be at a y value that's a whole number, it's now going to be a fraction. Let's look at the other approach I use whenever I have fractions. So I'm going to multiply everything by my common denominator. In this case, this is 4, so I'm multiplying my left side and my right side by 4. Distributing the 4 to my left side, I get 4y plus 16 equals, distributing this out, I will get 20 over 4 times this whole quantity, x plus 10. 20 over 4 simplifies to 5. When I distribute the 5 out, I end up getting 5x plus 50. To remind you, my goal is to solve for y, so I'm going to subtract 16 from both sides. And then to get y by itself, I will divide everything by 4. So my final answer will be y equals, this is 5 over 4x plus 34 over 4. And lastly, I know that this last part, my y-intercept, can be reduced because both of these are even numbers. And so when I divide the numerator and the denominator by 2, I get the same answer, that it is 17 over 2. So these are two different approaches to solving the same types of problems. Use whichever one you're most comfortable with. Let's try to do some word problems. After its purchase, the new value of the car decreases by $3,000 each year. Since this is decreasing, we know our value will be negative. Because it's happening every year, this is going to be our slope. This is the rate of change. After 3 years, the car's worth is $18,000. Write an equation in slope-intercept form that represents the value of the car x years after its purchase. So x will represent the number of years, and y will represent the value of the car. We have 1 point that's given to us. This statement, after 3 years, the car is worth $18,000. So that means our x value would be 3, representing the 3 years, and our y value is going to be 18,000, since that is the car's worth. So now we have a point, and we have our slope. We want to find the equation in slope-intercept form, so what we can do is use point-slope form first, and then move things around and solve for y to come up with the slope-intercept form. I'm going to do y minus my y-coordinate, 18,000, which equals m, which is my slope, negative 3,000, in parentheses x minus my x-coordinate, which is 3. Then from here, I'll distribute negative 3,000 to x, which is negative 3,000x, and then negative 3,000 to negative 3, which will be positive, so plus 9,000. Adding 18,000 to both sides, I'll get y equals negative 3,000x plus 27,000. And this I know is in slope-intercept form because I have y isolated by itself, and then I have whatever my slope is multiplied by x plus my y-intercept. Now our question asks, what is the original value of the car? So the original value of the car must have been when 0 years have passed. So that means my value for years must be 0, and years is represented by my x-coordinate. So I'm looking for what is y when my input for x is 0. So I can use that equation and plug in 0 in for x. 0 times anything would just give me 0, so I'm left with just this 27,000. As we know as well, if I'm finding the value of y when x is 0, that's the value along the y-axis. So that is just going to be my y-intercept, which is in fact $27,000. So that means when the car was first purchased, it was worth $27,000. Let's try the next problem. You water your plants at a constant rate. After 5 seconds, your watering can contains 58 ounces of water. 15 seconds later, your watering can contains 28 ounces of water. Write an equation that represents the amount of water in a can after x seconds. So x represents our time in seconds, and y will represent the amount of water in ounces. So putting this together, I have 2 points given here. I have 5, 58. And then 15 seconds later, that means it would be 20, 28. In the directions, it just says write an equation that represents this scenario, but it doesn't specify whether the equation needs to be in slope-intercept form or in point-slope form. So in this case, what I'm going to do is just use the 2 points to come up with the slope, and then I will just use one of them to write this equation in point-slope form. I think if it doesn't specify, the point slope form is the easiest to come up with because all you need is just the point and the slope. If I wanted to write this in slope-intercept form, I could either start with point slope and then distribute, move things around, and solve for y, or I could find the slope, use one of the points, plug it in, then find the y-intercept, then rewrite it. Wait, it's a lot more steps. So that's why I'm suggesting to just write the answer in point slope form. So my answer in point slope form, I can use either point. Let's say I use my first point. This would be y minus my y-coordinate, 58, equals my slope, -2, in parentheses, x minus my x-coordinate, so 5. And then this here would be my final answer for the equation that represents this scenario. The next question is, how long will it take to empty the watering can? So if I want the watering can to be empty, basically I'm asking that my ounces here, my y-coordinate, I want that to be 0. So I'm trying to find what is the x-coordinate when y is 0. And I'm going to plug in 0 for y. If I use my equation, I get 0 minus 58 equals -2 times x minus 5. On the left side of the equation, I just get -58. Distributing this out, I get -2, and then this would be plus 10. Subtracting 10 from both sides, I get -68 equals -2x. When I divide both sides by -2, I end up getting that x is equal to 34. So what that means is it will take 34 seconds to empty my watering can.